Drupa DNA is thrilled to have Dietrich. Couldn't get your last name. Van Segern.
Von Segern.
Van Segern from Callas. Thank you so much, sir.
Yeah, I will introduce you to my name, amongst other things, in this session. Yes, my name is Dietrich von Segern. I'd like to talk to you about one of my favorite topics, which, as she said, is PDF standards. So the one standard that you should probably all know is PDF itself, but then there are other standards building on PDF. Hello, welcome to the show. That's me. That's how my name is written. I'm working for Callas Software. I'm the CEO there. Our booth is right over there. We are doing PDF software. So every software that we release has to do with PDF and with PDF automation, processing PDF files in an automated way for print. PDF is important for us, and therefore I'm not just a CEO of the PDF of Callas Software. I'm also in the board of the association that develops and maintains the PDF file format. So that is a community of companies coming together in the PDF association, where I'm the vice chair and the board. I'm also responsible for the liaison, for the connection to ISO. The whole story started back in '99 when I became a printing engineer. So I have a background in graphic arts. I'd like to start with just a few spotlights, if you want, on what I think is important in the print industry as of today when we are looking at our topic, PDF processing. So we all know the communication is getting more and more digital. Where paper was used in the past, quite often you don't need paper anymore. Things are happening just online or via email. So digital somehow takes over. The amount of printed paper goes down. So that is obvious to all of us. Luckily, we have digital printing machines, and that helps us to cope with these challenges, with these changes. So we can, with digital printing machines, do smaller print runs. We can even go down to print run just one sheet, one substrate being printed individually with content. What does it mean for prepress? That is our topic here. While the amount of paper that is being printed may be shrinking, the amount of PDF pages that are to be processed at least doesn't shrink in the same way. So the amount of PDF files or PDF pages that are to be processed definitely goes up compared to the total number of sheets that are being printed. And that means if you want to deal with this increasing number of PDF pages, you have to do in an automated fashion what has to be done by people in the past. And that is where softwares like ours kick in. Is it an issue? So is prepress automation an issue? I would say yes, it is. And I know that from many support and customer cases. But what I would say from our software, the issue is not changing a PDF file so that it works on a printing machine. That is not the issue. You can basically automate everything in a PDF file. You can generate bleed where bleed is missing. You can add printer marks. You can embed fonts. You can change text. You can change colors. You can change the shape of objects. So you can do basically everything, and you can do everything in an automated way. So that is not the issue. The issue is, when do you want to do that? So how does the workflow know what it ought to do for your requirements? So, and that depends on the concrete PDF file that is being processed. So what has been submitted by your customer, usually the input PDF file, and it also depends on the workflow and device requirements. So, and now you want to bring those together. And that is a complex challenge. So you have, and PDF file in itself is very complex. So you have a very complex file format. You have complex requirements in your workflow. and that creates a very complex situation when you want to create an automated workflow. And the easiest way to reduce complexity here is use standards. So if you would use a standard, you can, on the one hand side, adjust your input files so that they comply with the standard. And on the other hand, you can adjust your workflow and your devices so that they also comply with the standard. So standards are a very important and quite easy to use tool to reduce complexity and reduce complex requirements for PDF automation and prepress. Yeah? And that is the agenda. These are basically the standards that I want to cover. Most of them are coming from ISO, so they are international standards, and a few, the other ones are coming from Ghent Workgroup. And we know so each company, each printer has individual requirements that depend on their devices and on their workflow. And then what I can't talk about each individual printer, but what I want to do is I want to talk about this topic by printing methods and print products. So first I want to talk about print in general, then about commercial print, which is still somehow general, then a few words, just a few words on large format, label and packaging, and variable data print. So first, thank you, PDF. So prepress PDF, prepress automation wouldn't be possible without a standard file format, and that is today PDF. So every prepress department more or less just deals with PDF files. Times when we got open files. So when I entered industry in 1991, it was Quark Express with external files, images, fonts separately, or PostScript, EPS files. As of today, we don't have to deal with this even more complex situation. We just have one file format, which is PDF. And we just need to deal with that file format. But PDF wasn't designed to be the file format for prepress. PDF was designed to be a replacement for digital paper. Adobe introduced it in the last century to replace paper, printed paper, that it was exchanged between offices, between companies, replaced it with a digital file format. And the nice thing was, from the beginning, PDF was designed to be complete. Fonts, images, everything can be in the PDF file, which is also good for prepress, of course. But it's a tremendously complex format, so it can do so many things, so it's very, very complex. So if we want to use it for prepress in the best possible way, we need to further think about it and maybe create additional rules for a PDF file that works as a prepress input file. A few examples, what you can do in a PDF file. It's not just a replacement of paper. So from a prepress point of view, a PDF page can not just be a page with some dimensions. It can have several geometry boxes. There is, first of all, the trim box that specifies the area of the finally cut page of the final print product. There can be the bleed box that specifies the area around that cut sheet of paper where the bleed is getting in. And then there is a crop box that specifies the whole area. You don't have to remember that. What I want to say with this slide is there can be things in a PDF page that are somewhat hidden and that make producing the PDF file and printing the PDF file much easier. For imposition, the size of the trim box is quite important. And it's also quite important to know whether there is bleed where needed. Other things, you can have metadata in a PDF file, additional descriptive data, But in a PDF file, you can have that not just with a document, as you can have with many, many file formats. You can also have metadata related to pages, to layers, and to images. And also that can be important for print workflows. So you would want to make sure that if you have a workflow that relies on such metadata, that you process PDF files that actually have it. And then probably the most important topic for prepress and print is color. PDF is very powerful here. Many file formats allow you to specify a source color space, an ICC profile that specifies this image was created with that camera, on that scanner, whatever. So you can have a source ICC profile, which is common in file formats. But in PDF, you can also have a destination profile. So a PDF page can tell you this image was created with that camera, and then it was improved and changed, and everything happened with an intention to print it, let's say, on ISO-coated. So you can say everything happened to that PDF page with the intention to be printed on commercial print. And now this very PDF page shows up in a newsprint production, and maybe it's an advertisement and a newsprinter wants to print it. Then he can use these two ICC profiles to soft-proof the image on screen and adjust it to the color space of his printing machine. So PDF is prepared for soft proofing, and of course it has full support also for spot colors, not just a single spot color, a red or the drupa red, whatever. It also supports multicolor, so larger color spaces than just CMYK. For instance, CMYK, orange, violet, and green. It can even have spectral measurements, so if you want to soft-proof how spot colors interact with each other when they're being overprinted, you can use spectral measurements that have been done with that spot color and that have been added to the PDF file in the form of CXF editions. So everything's possible, but not always there. So what we want to have additional rules. We want to have additional rules that tell us whether a PDF file complies to our requirements. And that is where standards kick in, additional standards, and first and most importantly for prepress we have PDFX, blind exchange, PDFX, ISO standard. It has two important, and I don't want to go into details, I just want to explain the general idea here. One principle is completeness, so a PDFX file needs to be complete. Everything that is needed to print it needs to be embedded, and that are most importantly images, fonts, and ICC profiles. And the other principle is unambiguousness, so everything needs to be clear. Color needs to be device independent, so not just CMYK, but particular CMYK color space, ISO-coated, ISO newspaper, whatsoever. And I talked about geometry boxes, the trim box, and so forth. Those boxes need to be there and need to be properly nested. So a bleed box can't be smaller than a trim box. Good thing to do. So if I do prepress automation, PDF automation, I should think about PDFX. Next question. There are several flavors. It's not just PDFX. There is PDFX 1A, PDFX 3, PDFX 4, there is PDFX 5, and recently also PDFX 6 was published. So which one to pick? I've noted one important difference between PDFX 1A and PDFX 4. PDFX 1A doesn't support live transparency, while PDFX 4 does. What does it mean? Transparency is a feature in PDF, so you can have objects in a PDF file. We have a very simple example here, just 3 colored rectangles that overlap each other, and they not just overlap each other, they overlap each other using transparency. So the green rectangle is overlapped by the red rectangle, but the green rectangle is not cut out. The green rectangle is still visible where it's being overlapped by the red rectangle. And that complicates the thing for a rendering engine. If you don't have transparency, you would just have a number of pixels. You would, in that area where the green is being overprinted by the red, just mark this is green, and when the red is coming, then you would delete the green and replace it with a red. Now you have to remember, here was a green, and then you'd have to do some calculations to somehow merge it with a new red and create a new color. I mean, it's doable. Every RIP, as of today, can do that and actually should do it. A RIP knows what is the final color space. So a RIP knows I'm printing for this and that color space, and then the RIP knows in which way the red is to be calculated with the green. So for instance, the red may be specified in RGB, while the green was specified in CMYK. So if you want to merge them, you would have to merge them into a new color space. So you have to decide whether the new color space is CMYK or RGB. Yeah? So that complicates things here. And then you have two choices. Either you do the flattening, so you create the new color beforehand in the PDF file, or you do it in the RIP. And what I want to say, you should do it in the RIP, because you can do transparency flattening in the PDF file, but that basically means you will have to create quite a big number of new objects just to demonstrate, just to show our very, very simple example here. So I haven't counted, but you create quite a big number of new objects, each one with a single color, to be able to display that originally 3 objects without using real transparency. So you would end up with a number of new objects just to create the same appearance. And that is easy for the file that we've just seen, but this is a real-world example that a couple of years created lots of problems throughout the prepress departments in the world because it was so complex. The original file had 8 megabytes and 4,000 objects already. The transparency flattened file has 77 megabytes and 20,000 objects, just because they were so tiny, small, transparent overlapping objects that created a huge number of objects that had to be processed then in the RIP. So with the intention to make things easier, by transparency flattening the PDF file, the result was things got much more complicated, just took much more time when being processed. So not a good idea to do that. And that means you should use PDFX4 at least. Sorry. You could use PDFX5 for certain requirements. If you are CMYK OVG or so, you should use PDFX5. You can use PDFX6 if you are on PDF 2.0, the latest release of the underlying PDF specification, but you shouldn't use these old PDFX standards back from 2001, and even PDFX4, I think that came out in 2005 or 2006, so it's still not brand new. Unfortunately, just as of today, we are seeing the transition. So I'd say, as of today, most prepress departments use prepress, but you can still find PDFX1 and PDFX3 around, which I think should change. So that's where we are, print in general. Let's now have a closer look into commercial print, large format, and so on. And that is the realm of GWG, the Ghent workgroup. The main issue with PDFX is that it's so general. So it covers all print methods, print products, so it can't specify a minimum image resolution because a newspaper has a different minimum image resolution than a commercial print or packaging. It can't specify a minimum text size because it doesn't know. That depends really on the print product. It can't say what is the minimum line thickness, so all of this is unspecified in PDFX. And it should be specified in a PDF prepress workflow. So we could use PDFX as a basis, but we should do something more. And that is GWG. A GWG specification has exactly that. A minimum image resolution, small text, has to have a certain minimum size. It specifies whether spot colors are permitted or not. It specifies for an advertisement, you would only have one page, where for a brochure, you would have several. So all such requirements are in GWG. And that means GWG is not just one specification. It is actually 34 different specifications for different printing methods and different print products. But it's easy, it's a specification, it's kind of a table, and each column has a name, and the name, for instance, is packaging offset or packaging gravure, so it's easy to pick the values that are for your printing method, commercial, label, packaging, large format, so just headlines with a smaller or more detailed specification each. Yeah, and one thing, large format, one slide on large format, because large format is somehow special. Large format is not just one limit for image resolution. The image resolution, the minimum image resolution depends on two parameters, the viewing distance and the scaling factor. So in large format, you would specify what is the typical viewing distance. Is this 1 meter or is it 20 meters? And then the minimum image resolution depends. The smaller the viewing distance, the higher the minimum image resolution. And then there's the scaling factor, because the original page is typically being scaled. So when you validate whether a page complies with GWG large format, you will have to enter the viewing distance and the scaling factor, and then there are the real limits being calculated, and you can find out whether the PDF page complies or not. That's that. So we've covered print in general, commercial, large format. Now label and packaging, just a very few slides on the remaining topics here. Of course, everything gets more detailed here, label, packaging. As I've already said, we have GWG, and GWG for label and packaging actually are 18 different specifications. You have 6 different products, like corrugated, label, and so forth. And then each one specified for printing methods, offset, gravure, and flexo. And thereby you end up with 18 different specifications. And each one has a typical limits, image resolution, and everything. But for packaging and label, the situation is even more complex, because your print file usually contains not just the print layout, it also has information for additional processing steps, if you want post-print processing steps. Most importantly, there is a dye line, there's a creasing line, there may be a varnish form, a white form, a legend explaining what colors are associated with, for instance, a cut line, a brailing, here in this example. And quite often, these additional informations are identified by using spot colors. And spot colors just use a name. So in Germany, you may use Stanzform in England or UK, you would use die line or just die or cut line. And then for a printer, it's difficult to find out where in the PDF file is my die line. And that is where the processing step standard kicks in, also an ISO standard, and that specifies you should use spot colors indeed. And it doesn't matter what the name of the spot color is. Important is spot color needs to be on a PDF layer, and that layer's name is also doesn't matter, but it has to have metadata, and the metadata is standardized. So for a cut line, there is a metadata where the group is structural and the name is cutting. Yeah? And then the printer can easily use that information to separate the cut line from the print layout. And the GWG relates to these processing steps to the ISO standard by requiring that every PDF files that want to comply with any of the packaging specifications need to use processing steps. Yeah? And customers of us, I mean, the intention or the idea here is printer talks to his customer and asks the customer to specify the die line using this metadata. As difficult as it always is in our industry, customer says, why? Printer says, yeah, it would help me, yeah, but I have so many other problems to solve. So you probably all know that if you're from printing space. We have customers that say, okay, we try that. If we fail, we just fail. But what we do whenever we receive a file from such a customer, as a first step in our workflow, we normalize. And normalize means they look into spot colors, and if the engine can identify a spot color with die or cut or stanze in its name, it would just add the metadata. It would put it on a layer and would add the processing steps metadata. And from then on, the PDF file is normalized and can run through the internal workflow supported by this ISO standard processing steps. Yeah, and then you are prepared. So if a new spot color is used for a die line, you can just simply adjust one step, the first step in your workflow, just add that name to the list of supported spot color names, and then from then on, you don't have to change anything else in your workflow. Reduce complexity. Finally, variable data print, yet another quite complex area. There we don't have GWG, we have an ISO standard PDF-VT, which stands for variable and transactional printing, and we have another ISO standard print product metadata. Just briefly, in variable and transactional printing, the main issue is optimizing for the print output for mail delivery. Yeah, so most national mail organizations, paper mail organizations, give you better postage prices if you're able to deliver print products, paper assorted to zip codes. And that means you want to print according to zip codes, and that means you would want to find out which page is designed to go to what zip code. Of course, you could read the PDF page, but that would be complicated, and then you have maybe an invoice that consists of 5 pages, and then the zip code only is on the first page. So much easier would it be if you have metadata in the PDF file that says, here is a new record, and that should go to this or that zip code. And then you could just separate the pages for a zip code, for a given zip code, and print that together. And that is possible using metadata that is specified in PDF-VT. Unfortunately, PDF-VT only tells you in what way you can add the metadata to the pages, but it doesn't tell you what the field name is for a zip code, for instance. So still, someone could say, I use zip, and the other use the German Postleitzahl. It doesn't help. And that is where print product metadata kicks in. That standardizes address information so that you can use it in a PDF file. Of course, the whole thing is much more complicated than I can describe here in one slide. Luckily, there is a new brochure just published by the PDF Association, by SIP4 people, together with PDF Association, including myself, but also others. If you're interested in that brochure, you can get your copy over there at our booth. What else can you get over there? What does all of this have to do with callas software? We don't have a workflow. We can't support you with a complete workflow for a print house. What we have is an engine that can adjust PDF files for printing requirements. A quite complete engine developed for automation purposes called PDF Toolbox. It has, of course, profiles for all the GWG profiles and many, many more profiles. GWG profiles are a very good starting point for automation and then just taking away what is not needed, adding requirements or corrections that are needed. If you have any concrete questions, let us know. Just turn around, and there's my colleague Mark. Prepared. He already is looking forward. And that is what I wanted to say. Thank you for being here with me.
Thank you very much, Dietrich. I think if there are any other questions, please find Callas at their booth. And I hope I see many of you back here at 3.